Good morning, my dear students. I am extremely happy to meet you all through such video presentations once again. In the previous video presentation, we were discussing about zeros of the polynomial, linear polynomial as well as quadratic polynomial. Let me just have a quick recap of the whole lot. Okay, just take y is equal to minus x plus 2. Okay, this is as equal as x plus y is equal to 2. It is a straight line, x plus y is equal to 2. Therefore, I'll be plotting point 2 comma 0. I'll be plotting point 0 comma 2, and this will be simply the straight line passing through x plus y is equal to 2. This is my x-axis. This is my y-axis. This is my x-axis. This is my y-axis, my origin. This is 1, 2. This is 1, 2 on the positive directions of x and y-axis respectively. Okay, I have just taken y is equal to minus x plus 2 or x plus y is equal to 2. When y is 0, x is equal to 2. It passes through 2 comma 0. When x is 0, y is 2. Therefore, it passes through 0 comma 2. Therefore, it is the straight line x plus y is equal to 2. If I am going to think about 0 of minus x plus 2, I should equate it to 0. I'll get minus x equal to minus 2. Therefore, x equal to 2. Therefore, 0 of the linear polynomial minus x plus 2 is nothing but 2. Geometrically speaking, I will just draw the straight line y equal to minus x plus 2, which is the same as x plus y is equal to 2. I am supposed to identify the point where it intersects the x-axis, and x coordinate of that particular point where the line intersects x-axis will be the 0 of the polynomial minus x plus 2. Strictly speaking, every straight line, okay, except the line parallel to x-axis will definitely intersect the x-axis. Okay, will definitely intersect the x-axis. Therefore, you will have a real 0 for such a point is called a real 0. Okay, it has a real 0. It has a real 0. Okay, therefore it has a real 0. Okay, therefore I repeat, when I am going to be given the linear polynomial minus x plus 2 equated to 0, I'll get minus x equal to minus 2, s equal to 0. Therefore, 0 of the polynomial in general, the point at which or the value of x for which the polynomial becomes 0 is known as the 0 of the polynomial we have seen. Therefore, 0 of minus x plus 2 is x equal to 2. How to identify the same? Using your, what do I say? Geometrically. How to identify such a 0 geometrically? I'll take the line y is equal to minus x plus 2. Okay, it is the same as x plus y is equal to 2. Okay, when y is 0, x is 2. When x is 0, y is 2. Therefore, it is a straight line passing through 2 comma 0 and 0 comma 2. Identify the point where this line intersects the x-axis. X coordinate of that particular point will be the 0 of the corresponding polynomial. This is how we get 0 of a polynomial, linear polynomial. Linear polynomial. Okay, you will have definitely a real 0 unless otherwise it is parallel to x-axis. It will definitely intersect the x-axis. It will definitely intersect the x-axis. Okay. Now we have seen, you can take another example. X square minus 8x plus 12. Let us say. Okay. Here you mean to say automatically. Okay. Just listen, equate it to 0. I can split the middle term. Minus 2x minus 6x plus 12 is equal to 0. You might have learned in lower classes, sum of two numbers is minus 8. The same two numbers should give you 12. For minus 6 minus 2. Minus 6 into minus 2. Therefore, I can factorize x into x minus 2 minus 6 into x minus 2 is equal to 0. You can just verify. Okay, x into x square, x into minus 2 is minus 2x, minus 6 into x minus 6 is minus 6 and minus 2 plus 12, which will imply you x minus 2 into x minus 6 equal to 0. Product of two numbers is 0 means either this is 0 or this is 0. That is possible only when right hand side is 0. It is not applicable when right hand side is other than 0. Remember carefully. Or x minus 6 equal to 0 implies x equal to 2 or x equal to 6. X equal to 2 or x equal to 6. Okay. In fact, therefore, zeros of x square minus 8x plus 12 or Okay, I mean to say 2 comma 6, that's the meaning. Here, how to draw the graph? How to draw the graph? Let me make use of this particular slide. Just listen carefully. I'll take it as y is equal to x square minus 8x plus 12. I'll try to make it as a perfect square. Okay, plus 12, add 16 and subtract 16. I'll get x minus 4 whole square minus 4 I will get. Okay, now this is as equal as y plus 4 is equal to x minus 4 the whole square. Let me just repeat. You are given, I am taking it as y is equal to x square minus 8x plus 12. Now for x square minus 2 into 4x becomes a perfect square by adding 16 and to just compensate, subtract 16 over here. Now for 12 minus 16 is minus 4. Now for this is x minus 4 the whole square, x square minus 2 into 4 into x plus 4 square. Now for this is as equal as y plus 4 is equal to x minus 4 the whole square. Y plus 4 is equal to x minus 4 the whole square. Okay, therefore I can, as I did in one of the cases earlier, I can just think about when x is equal to 4, y is minus 4. Listen carefully. When x is equal to 4, just listen carefully, y is minus 4. Am I correct? Just x is 4. 1, 2, 3, 4. When x is equal to 4, y is minus 4. Therefore, it passes through. What do I get? It passes through 4 comma minus 4. 1, 2, 3, 4. It passes through 4 comma minus 4. This is one point, one such point. Let me just repeat. When x is equal to 4, y is 0 minus 4. Y is minus 4. Therefore, it passes through 4 comma minus 4. Just listen carefully. Then y is equal to 0 is the equation of x-axis. I already told you. Now, for putting y equal to 0, I will be able to solve x minus 4 whole square minus 4 is equal to 0. Now for x minus 4 whole square is equal to 4. Now for x minus 4 is equal to plus or minus 2. X minus 4 is equal to 2 or x minus 4 is equal to minus 2. Now for x equal to 6 or x equal to, in fact, 2. 2, 6 we have already seen. We have already seen by factorizing this 2 comma 6 or the 2 elements I have seen. Therefore, substitute zeros of x square minus 8x plus 12 by factorizing we have seen already. I am getting it in a different manner also. I repeat, put y equal to 0, x minus 4 whole square minus 4 equal to 0, x minus 4 whole square equal to 4, x minus 4 is equal to plus or minus 2, x minus 4 equal to 2 or x minus 4 equal to minus 2, x is 4 plus 2 which is 2, 4 minus 2 is 2. Therefore, zeros of this is obtained in a different manner, 6 and 2. Therefore, it means that when y is 0, x will be 6 comma 2. Therefore, it passes through 1, 2, 3, 4, 5, 6. Therefore, it also passes through 2 comma 0. Therefore, plot these points also. Therefore, the curve will be a smooth curve like this. I have to join these 3 points with a smooth curve. Okay, it will be a smooth curve like this. Okay, you have to draw a smooth curve joining these 3 points. Therefore, after drawing this, remember carefully, after drawing this, it has a vertex. This point is called the vertex of the parabola. 4 comma minus 4 passes through 2 comma 0, passes through 6 comma 0. You can just check 2 minus 4 the whole square is, of course, 4 minus 4 is 0. 6 minus 4 is 2 square, 4 minus 4 is 0. It passes through 2 comma 0, 6 comma 0. When x is 4, y is minus 4, it passes through 4 comma minus 4. Therefore, I'll have a smooth curve joining these 3 points. It is known as a parabola. Okay, if you identify this parabola intersects the x-axis at 2 comma 0 and 6 comma 0, and x-axis of those 2 points will be the corresponding zeros of the polynomial. In fact, those 2 are real zeros. If the numbers are real numbers, I call them as real zeros. If the numbers are real numbers, I call them as real zeros. Actually, here I have 2 real zeros which are not equal, unequal or distinct. I repeat, I have 2 real zeros which are not equal or unequal or distinct. That is how we say. Okay. Therefore, identify the points where the quadratic polynomial intersects x-axis. X coordinate of those points will be the corresponding real zeros of the polynomial. Remember carefully. In most of the textbooks, they simply call it as 0. It's better to have it as real zeros. Mention them as real zeros. Okay, just take y is equal to x square. Okay, just listen carefully. I already told you in the previous video that we'll think about coincident zeros or equal zeros. Okay, by an example I already told you. Take y equal x square. It passes through 0, 0. It passes through 1, 1. It passes through 2, 4. Okay, it passes through 2, 4. Similarly, it passes through minus 1, 1, then minus 2, 4. And for this will be a curve like this. This is how the graph goes. Actually, equate x square equal to 0. What do I get? X equal to 0. I have real 0, 0. Both are equal. Both it touches the x-axis. In such cases, I am going to get the curve touches the x-axis. Instead of intersecting the x-axis at two distinct points, if the curve touches the x-axis, I'll have two real zeros which are equal. Let me repeat. If I take y equal to x square, when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 4. When x is minus 1, y is 1. X is minus 2, y is 4. Therefore, joining these points, I'll get a parabola like this. Actually, unlike the previous one, in the previous case, the curve intersects the x-axis at two distinct points. Therefore, I'll get two real zeros which are unequal or not equal or distinct. I already told you. Here it will just touch the x-axis. Therefore, the x-axis is a point where it touches the x-axis will be the corresponding equal zeros of the quadratic polynomial. Remember carefully. Similarly, I can think about a curve like this. I'll get a curve like this passing through 1, 0. I'll get a curve like this passing through 2, 0. I can have a curve like this passing through 3, 0. This will be x minus 1 whole square. I can think about here x minus 2 whole square, y equal x minus 3 whole square. I can have infinitely many such cases. I can think about various such cases. Therefore, I repeat once again, if I am going to draw a quadratic polynomial, it will be always a parabola. We have seen by various examples. Okay, when the parabola intersects the x-axis at two distinct points, remember carefully, when the parabola intersects the x-axis at two distinct points, then x coordinate of those 2 points will be the corresponding real zeros of the given quadratic polynomial. I may have a case like this. I have taken an example y is equal to x square. It passes through 0, 0, 1, 1, 2, 4, minus 1, 1, minus 2, 4, and so on. It is a parabola like this. Here it touches the x-axis at 0, 0. X coordinate the point 0, 0 is 0. Therefore, I have two zeros which are equal, coincident. Either way you cannot distinct, either way you can say. I can have infinitely many such cases. I have y equal to x minus 1 whole square. It will be like this. Y equal to x minus 2 whole square. Y equal to x minus 3 whole square. I can have infinitely many such cases. Need not be always a whole number. It can be a fraction also. Okay. I can even think about if I am going to have y equal to minus x square. It will be like this. Similarly, y is equal to minus x minus 1 whole square. It will be like this. It may phasing downwards also. It may phasing downwards also. Okay, this is how we get equal zeros which are real numbers, real zeros. Just take an example like this. Y is equal to x square plus 1. Just listen carefully. If I am going to do with the usual process, just listen carefully. I'll get x square equal to minus 1. Here I mean to say x square equal to plus or minus root minus 1. I call it as a complex number. I call it as I. Root of minus 1, I call it as I, which you are going to learn only in higher mathematics. Here I won't say you don't have zeros. Remember carefully. I will have zeros for x square plus 1 also. But here the zeros are called not real or unreal or complex or imaginary. I can express in 4 different ways. I repeat, if I am given y is equal to or x square plus 1, simply the quadratic polynomial x square plus 1, equate it to 0, I will get x square equal to minus 1, x equal to plus or minus root minus 1, I call it as I. I will not say there is no 0, it is totally wrong. It's better to say I have two zeros which are not real or unreal or complex or imaginary. Such numbers are called complex numbers or imaginary numbers. Just to draw, how do you draw? Just listen carefully. It passes through 0, 1. Okay, when x is 0, y is 1, 0, 1. Okay, this is 1 point. And it passes through 1, 2. Okay, it passes through 2, 5. 2 comma 5. Similarly, minus 1 comma 2 and minus 2 comma 5. These are the points you can draw. If you look at the graph carefully, it will not intersect the x-axis at all. Therefore, whenever I am going to draw the graph of any quadratic polynomial, just listen carefully. Whenever I am going to take the graph of any quadratic polynomial, it will be again a parabola which if they have imaginary zeros like this, it will not intersect the x-axis at all. It will be above x-axis or it may be below x-axis. Therefore, I may have graph like this. Okay, whenever I am going to graph like this, such quadratic polynomial will have no real zeros. It's better to say no real zero or complex zero instead of saying no zero. I repeat, I have taken x square plus 1, the quadratic polynomial x square plus 1. Okay, equate it to 0, I will get x square equal to minus 1. X equal to plus or minus root minus 1. I call this is I, which you are going to learn only in higher mathematics. Okay, therefore, such zeros are called unreal zeros, or not real, or complex zeros, or imaginary zeros. Okay, while you look at the graph, when x is 0, y is 1, when x is 1, y is 2, when x is 2, y is 5, when x is minus 1, it is again 2, for minus 2, it is 5, therefore it will be a parabola like this. If you get the graph of such a parabola, it will not intersect the x-axis, it will never intersect the x-axis, it will be above the x-axis, below the x-axis, as drawn in the various cases like this. Therefore, whenever I am going to think of a quadratic polynomial whose zeros are imaginary, it will not intersect the x-axis at all. Or if I am going to have a graph which does not intersect the x-axis at all, okay, such quadratic polynomial will have imaginary zeros, no real zeros. That's the meaning. Okay, remember the difference between real zeros which are distinct, real zeros which are equal, and complex zeros Remember the difference between the three. Okay, now it's better not to say simply, okay, there is no zero if the curve does not intersect the x-axis. I repeat once again, if the curve intersects the x-axis at 2 points, I have 2 real zeros. If the curve intersects the x-axis at only 1 point, I have 1 zero. Okay, if the curve intersects the x-axis at 3 zeros, I can draw a graph like this. Okay, 3 points, I mean to say there are 3 real zeros. Instead of saying simply 3 zeros, it's better to say 3 real zeros. Okay, if the curve, let us say, intersects at 4 points, 1, 2, 3, 4, 1, 2, 3, 4, I have 4 real zeros. You can just think about. Okay, and if the curve touches the x-axis, okay, touches the x-axis like this, okay, if it is a parabola, I have 2 real zeros which are equal. And if the curve does not touch the x-axis at all, it's better to say I have unreal zeros or not real or complex zeros. Don't say no zero. Therefore, whenever I am going to draw a graph which is a linear polynomial, which is a straight line, I have one which intersects x-axis at only 1 point. I mean to say I have 1 real zero. If it has intersects x-axis at 2 points, I have 2 real zeros which are distinct. I have a parabola which touches the x-axis, I have 2 real zeros which are equal. I have a curve like this, 1, 2, 3, there are 3 real zeros, intersects x-axis 3 points, 1, 2, 3, 4, it intersects x-axis 4 points, I have 4 real zeros. Here, I mean to say, for these 2 cases, I won't say there is no zero, I should say there is no real zero for the given quadratic polynomial. That is the meaning. Given polynomial, you can say, if you are not able to identify whether it is cubic or quadratic or 4th degree. For I mean, by looking at the graph, I have to identify the various different possibilities like this. Okay, I think I'll do the rest in the next video. Those who are interested in having automatic notification of the new videos being uploaded in the channel, please subscribe by clicking the subscribe button as well as the bell icon. Thank you, students, for patient watching. A small correction. Whenever the curve intersects the x-axis at some points, the x-coordinate at the corresponding point will be the 0 of the polynomial, I already told you. But in some cases, by mistake, instead of saying x coordinate the point, it is wrongly said x-axis is the point, which is wrong. Please make the correction. It's an error from my end. Okay, it should be x coordinate at the corresponding point where the curve intersects the x-axis, not the x-axis is the point. I am sorry. Okay, sorry for the inconvenience. Thank you.